In this video, we are going to continue with linear programming. You will find this on page 325 in the Namibian Ordinary Level Mathematics textbook Y equals mx+c to success. Finding the minimum or maximum value. The maximum profit or a minimum cost expression is called the objective function. We find the minimum profit or maximum cost in the bounded unshaded part. That's where we were writing the R. This region is normally a polygon and is called the feasible region. We find the minimum or maximum value of the expression by using the vertices, corner points of the feasible region, or the points along the side of this region. Any point in the feasible region or along one of the solid lines is a possible solution. However, we are usually required to find the best, most profitable solution. It is usually at one of the vertices or at a point closest to the vertex. Let's look at an example. From the diagram, give the coordinates of the vertices of the unshaded region. Okay, so it's solid lines, and because it's solid lines, I can take the corner points, the vertices. Okay. At which vertex is the value of x plus 3y a minimum value? So just take that coordinate points and substitute it in. Then I will get 13, 4 and 7. And then write down the coordinates of all the other points in the region whose coordinates are integers. So just take the integers. Integer, 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 all that points. Let's just show you. Other points in the region, it's all the integer coordinate points. And is the value of this expression at any of these points indeed more than the maximum value at B or less than the minimum value at C? So just go and substitute all that points into that expression. So if you substitute the points in the expression, you get all these values. So now, all the values are between 4 and 13, because what was the extreme values? 13 and 4, but none of these values were close to that extreme. They were all in the middle, and that's why this example shows you that the maximum or the minimum points of an expression will be closest or on the corner vertice points, vertex points. Okay. I want you to stop the video and I want you to do, okay, it's just going to be, yes, I just want to see if all of them are solid lines. Yeah, it looks to me like all of them are solid lines. So just do for me number A as well as number D. You can continue the video as soon as you are finished. Try now 24. Let's start at try now 24. Refer to the diagrams below and answer the following questions in each case. From the diagram, give the coordinates of the vertices of the unshaded region. So let's start with A. So if I look at that one, it doesn't matter, I can start with this one. It will be 2 and 7. This one will be 2 and 4. This one will be 8 and 7. Okay, so that will be the first question. Now they ask you, find the vertex at which the value of the given expression f as a, there is f, so in this case, the expression is x plus y. So if I look at the first point, so I can write it like this, 2 and 7. So 2 plus 7 will be 9. 2 and 4. So 2 plus 4 will be 6. And 8 and 7 and 8 plus 7 will be 15. Okay, and that's the values. So what is the question? Find the vertex at which the value is having a maximum value. So therefore, at the point, maximum at the point 8 and 7. Okay. Then the next one, find the vertex at which the value of the given has a minimum. And I think it's already, we can just look at the values. So if that was the maximum, then this will be the minimum. Okay. So therefore, minimum at the point 2 and 4. Okay. Okay. Let's go on. So if I look at the next one, find the vertex at which the value of the given x is a minimum value. Write down the coordinates of all the other points in the region whose coordinates are integers. I first want to just show you the points. So let's just mark the points, all the other points. Okay, so that will be a point that because it's solid lines, that is already taken. All this will be points. Okay, that one is already taken. Okay, so let's just write down all that points. So if I'm writing down all that points, okay, let's start. It's 2 and 5. It's 2 and 6. It's 3 and 5. It's 3 and 6. It's 3 and 7. It's 4 and 5. It's 4 and 6. It's 4 and 7. It's 5 and 6. It's 5 and 7. It's 6 and 6. It's 6 and 7. And it's 7 and 7. So all that will be the points. Okay, then the next question. Is the value of the expression at f at any of the points in form more than the maximum or less than the maximum? So I'm just going to show it to you like this. I can just add it up now, all the different points. Let's just see. So if I add it up, and I'm just going to write it here, this is going to be 7, this is going to be 8, this is going to be 8, this is going to be 9, this is going to be 10, 9, 10, 11, 11, 12, 12, 13, 14. Okay, but now, what was the minimum point? 15. So was there anyone 15? No. What was the minimum? That was the maximum point. The minimum point was 6. Was any of them? No. So this exercise is just actually to show you that the extreme values, the lowest and the highest, will always be at the vertices. Okay, and that's that. And if we do the next one, number D, let's just make space. Okay, so start again from give the coordinates of the vertices of the unshaded region. So again, it will be this, 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 and this. So the points will be, this is the first one. The point will be a -2 and -1. Okay, the next one, okay, the next one will be 0 and 3. The next one will be 3 and 3. And the next one will be 3 and -1. Let's just see 3 and -1. Okay, and now we're going to move on, so to the second one. So find the vertex at which the value of the given expression has a minimum, not maximum, minimum. Now what was the expression? It's just, it's again x plus y. I should have taken this one, which is 2x plus y, but now it's too late. Okay, so it's again x plus y. So the expression is x plus y. But if it was 2x plus y, I will just multiply the value of x 2 times. Okay, so it doesn't matter. So if I just look at these points, then this is going to be -3, and this is going to be 3, and this is going to be 6, and this is going to be 2. And I ask you as a maximum, so therefore maximum will be at 6. Okay, so it will be this one, and which one gave it was this one. Let me just, so maximum at the point 3, 3. Okay, at the point 3, 3. Then the next one, find the vertex which is given as a maximum value. Then the next one is find the vertex given is a minimum. So the minimum and now I must, this is this -1, so it will be -2 and -1. Okay, and then I'm going on, write down the coordinates of all the other points in the region. Now again, there's quite a lot, but let's just mark them. Okay, I think I'm first going to clean this ones, make it a bit bigger, that I should just show you, and then I will just write it down. So if I must look at all the points, then I start. All that points. Okay, so let's start writing them down. It's all that, the rest is already in, so it must be integers. So if I look at that points, then they will be, now let's start writing it down. So it's -1 and -1, and it's -1 and 0, and it's -1 and 1, and it's 0 and -1, and it's 0 and 0, and it's 0 and 1, and it's 0 and 2, and it's 1 and -1, and it's 1 and 0, and it's 1 and, let's just go 1, and it's 1 and 2, and it's 1 and 3, and it is 2 and -1, and it's 2 and 0, and it's 2 and 1, and it's 2 and 2, and it's 2 and 3, and it's 3 and 0, and it's 3 and 1, and it's 3 and 2. And there is all the different points. Okay, and then the next question, it was just that red that I was writing down there. And then the last question, is the value of the expression f of any of the points in this more than the minimum or less than the, so basically I must just now add this up. So if I start adding it up, then I will get -2, -1, 0, -1, 0, 1, 2, 0, 1, 2, 3, 4, 1, 2, 3, 4, 5, 3, 4, 5. Now if you look at these values, is there one that's even reaching the highest, the maximum? No. Is there one that's reaching the lowest, -3? No. So no. You can just end by saying no. Now let's just get the pen. No. All the values are between -3, which is the minimum point, and 6, which is the maximum point. Okay. Let's go on. Let's just look at this one, this next example. In the region defined by this, find the point with integer coordinates where the values of this is a maximum. Now in the previous one was solid lines. Now this is not solids. This is broken or dotted, and this is solid. So I cannot take a point on the vertex. I can take a point close to the vertex. So if you look at this one, and I'm going to mark it in red, I can take the point -3 and 1. There, I marked it already. And I can take this point, and this point, and this point, because I cannot take points on the line either. So I can only take, that's the closest I can come to the vertices. And now I'm just going to take my expression, I substitute, and then what is the question? Find the coordinates where the value is a maximum. So which one is the biggest one? It will definitely be 8. And what will the points be? 2 and -1. 2, 2 and negative. So it will basically be this point. Okay. Okay. I want you again to stop the video, and I want you to do try now 25, number 1. You can continue the video as soon as you are finished. Okay. For the regions defined by the set of inequalities, draw a diagram and find the points. Okay, now if I draw the diagram, remember I think it's only positive, so it's not difficult lines. So, okay, let's just first write down the lines. So, oh, sorry. It's going to be, I still struggle with the pen. X is bigger and equal to -1. Y is bigger and equal to -2. And x plus y is smaller than 3. Okay, so if I draw my grid, now if I just draw, okay, let's just mark the numbers. So this is 1, 2, 3, 4, 5, 6, 7. Okay, and this one is going to be, oh, is there negative values also? Yes. So I have to extend that a little bit. Let's just see. I don't think it's so negative, so if I can just extend it to -1, -2. Bring this there. Okay, -1, -2. Okay, and then this one will be 1, 2, 3, 4, 5, 6, 7, 8. This is my x-axis, this is my y. So -1, so x is equal to cuts the x-axis and it cuts at -1. So it's basically cutting there. Okay, Then y is cutting the y-axis. Okay, so let's just say this is x is -1. Then it's cutting my y-axis and it's cutting in 2. And this is equal to -2. And then remember what I said, if it's 1x plus 1y, whatever that constant, it just means that it cuts at 3, 3. So basically that line will just be like this. I just want to extend it a little bit. Okay. If I really want to extend it, because I want to take it to -2, now I'm going to use a table now just to help me a little bit. Because I know it cuts at 3, but the graph is a bit bigger. So if I want to say -2, and I want to have 6. So then remember, if I make it, then it's y equals -x plus 3. So it's 2 plus, okay, that's going to be positive, so it's going to be 5. And that's going to be -6 plus, so it's -3. Okay, so it's at -2 and 5. Let's just see if it's working. And it's at 6 and -3. And then I just take that line. Oh, sorry. Just take the ruler. Okay, that's better, because now you can see. Otherwise, it was just too short. So just go for a table then. Okay, then I ask you, find the minimum. So now you already know. You don't have to test all the points. You also know that, no, this is not solid lines. It's not a solid. This last one, and I just want to indicate, was a broken. And that makes, okay, that was solid, broken. But it makes that I cannot choose that point. And I can also not choose this point. I can only choose a point which is close to that point. So if I choose a point, I can choose the point, in this case, let's see what points I'm going to choose. I can take this point. That point will work. I can take this point. That's all right, because it's solid lines. Again, I think I will take this one. So let's just write down the points. So I choose the points. It will be -1 and -2. And it will be -1 and 3. And it will be 5 and -2. 5 and -2. Okay, let's just see. I just want to see x is -2. So this is going to be 5 and -2. Okay, y equals the, I think it's rather going to be 4 and -2. Okay, I just want to see if that point will be on the line, because this will be a broken line. So that will be a minimum and that will be the maximum, and that's the broken. And if I look at that point, 5 and -2 now, because it's that broken line. So let's just go further. So it's 4 -2. And then I'm going to do the test. And if I do the test, I'm going to take the expression. What is the expression? It's going to be 2x minus y. So I substitute, let's first substitute all points. So if I do that, it's going to be 2, okay, remember x, y, x, y, x, y. So 2x -1 minus -2, that's the first point. Okay, and then the other, this is the point, -1 and -2. It's not good to write in your graph. Let's not do it. I don't like it. Okay, work underneath your graph, but not in your graph. Okay, so even that, you can even do that. So I just need the points. So if I write down the points, it was -1 and -2. and it was -1 and 3. And it was 4 and -2. And if I'm now going to take my expression, and don't forget my expression, every time is 2x minus y. So if I'm taking it, okay, 2x minus y, 2x minus y, and I substitute 2, -1 minus -2. And I substitute 2, -1 minus 3. And I substitute 2, 4 minus -2. And that will give me an answer of -2 plus 2, -2 minus 3, 8 plus 2. And that will give me 0, and that will give me -5, and that will give me 10. Okay, so if I look at this value, then I will say, therefore, this is A. It's going to have a maximum. This is your maximum at 4 and -2, and it will have a minimum at -1 and 3. Okay, so there's my minimum, -1 and 3, and there is my maximum. And that's how I do it.